we're going to find the definite integrals graphically. So the first thing I want you to do is turn this into y equals x plus 2. And I want you to graph that equation. Okay? It's a line. We should all be able to do that. So it's a positive 2 intercept with a 1 slope. And we're going to make a small table of values. Mostly, we're just going to plug in the 2 endpoints that are given to us in the integral. So we've got a few exact points on the graph. Okay. And then I want you to shade the corresponding area for that definite integral. So I've labeled the endpoints, and then I'm going to shade the area. Notice that it creates a trapezoid. It's creating a geometric shape that you can find the area of. On a quiz, it would say, use geometric shapes. Then I want you to draw it and find the shape and calculate the area. You have to read the directions. I want the shapes. Find the shape. Now, could you split this into a rectangle and a triangle because you're like, oh, I forgot the trapezoid? Yeah, sure. Okay, it doesn't matter, but you have to use area formulas. Okay, so I'm going to write down my trapezoid formula. And I luckily wrote down my 2 endpoints here, right? 0, 2, and 4, 6. So my delta x is 4 units wide. My first y coordinate, my second y coordinate. Okay, so this is 2 times 8. So the area is 16. Can you use the calculator to help you graph it? Sure. But I still want to see the sketch that goes with it. All right. Go ahead. Now that's x over 2. That's really just 1/2 x. Okay, draw it. Sketch the area that's being described by the definite integral. Okay, so this one, y-intercept of 0, I'm going to just jot down -4, right? So I added a middle point here, and I get -2, 0, 2. It's a 1/2 slope. And I'm shading my area between here and here. Notice that the ideas we learned about last class with sine area still applies. That first section would be negative. That second section would be a positive. But they're symmetric? So the answer would be 0. If they're symmetric, let them cancel each other out. Now I could do 1/2 base times height negative because it's below the axes. Okay, so that first section is -4. The second section, 1/2 base times height, is positive. Well, the two triangles combine to 0. Okay. You might remember how to graph absolute value. But go ahead and graph that first. Right? Just x minus 1. I'll do it with pencil so that we can see this. Okay. That's here. And I'm going to darken in my axes here just so it's a little easier to see. Okay. Now, we learned last class that absolute value reflects the bottom half to the top half. And so I'm going to take this portion of my graph, I'm going to flip it up. That's where the absolute value shape comes from, is it comes from reflecting to the top half. Can you remember that that's shifted right 1 and that's where the vertex is? Sure, you can. Okay, let's say you're like, oh, Mr. Breezy, I don't remember how to graph any of those things. Okay. Y equals math number ABS, x minus 1. There's your graph. Now I'm going to change my window and I'm going to zoom in a little bit. Okay. Right? It's fine. Use your calculator to help you graph it. Just make sure you get the correct graph. Now, I'm going to label a couple points here. So, this is y equals math number absolute value. Make sure I can graph that. Okay? And shade. From -2 to 5. All right? -2 to 5. 1, 2, 3, 4, 5. Okay. So I have 2 sections. I have 2 different triangles. I am going to include the table of values here just so that I know where these points are. I'm going to put -2. I'm going to put 1 because that's where the sections are changing. And I'm going to put 5. Positive 3. I didn't shade far enough. It's over here. Okay, there we go. There's my graph. Okay, 1, 0, and 5, 4. Okay. With those numbers, you should be able to calculate the area of both triangles. 1/2 base times height. One half, 1, 2, 3, 4, base times height. 9/2 plus 4. Plus 8, just kidding. Plus 8. 12.5. 12.5. Okay, see if you can do D and E. Right? Use your calculator as needed to create the graphs. So you're looking at D and E. So this is y equals -3. And so from -1 to 3, it's just a horizontal line, okay? And it goes from this point, -1, 3, all the way up to this point, which ends up being a rectangle. Now, if I look at that shape, right, that area is below the axes. That means that it's negative because of the sine area, right and down. And so the shape is 1, 2, 3, 4. That's length times width, but it's negative for the direction. And so you get -12. Okay, so we started here, so it's right and down, which gives us the negative area. Always make sure to keep the axes available so that you can see the orientation. And we always shade towards the x-axis and stop when you get there. All right, so I see this one. All right, I know its absolute value, and so I'm going to start by graphing 2x plus 4. 2, 3, 4, +2 slope. Okay, so this keeps going up here. And instead of going down, I know it's going to reflect up. There we go. There's my graph. Right, very lightly I had it here, but I reflected it for the absolute value. Okay, -2 to +3. Well, let's make a table. Make sure we know where these endpoints are. -2, which I can see is 0, and +3. So that's 10. Right, way up here at 10. Okay, and shade. In this particular case, it's just a triangle. Okay, 1/2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. Right, why did I plug in the coordinates so I would know exactly how high it was? 50, 25. Positive, right and up. Oh, okay. Well, let's try this one. Y equals square root 4 minus x squared. It's kind of weird to mix radicals and squares. What happens if you square both sides? Does anybody remember what this looks like? Kind of. Let's go ahead and, it's like a circle. That's the circle. But let's go ahead and graph it to make sure we plot the points correctly. Okay, so we're going to graph it as is and see if we can't use our calculator to help draw it. Okay, square root 4 minus x squared. The grid's pretty small, so I'm going to leave it in this -5. Okay. Kind of looks like an oval, but try to take those points off of the graph. -2, 0, +0, 2, and 2, 0. And connect them in the right shape. Yeah, that's half a circle. But notice it's the top half of the circle. I suggest that you remember that that's a circle. Okay? You should be able to recognize that, especially if you type it in your calculator and you're like, oh, okay, I kind of see the shape. That's a half of a circle there. Now, this is a radius of, what do we think? 2. The radius is 2 based on the diagram because you can see the center here. Okay, and shade. Well, it's only half a circle. So we're going to use our geometric shapes to find the area. And then I'll show you how to check it to make sure you did it correctly. Half pi r squared. R squared. Okay, so we get 2 pi. And you're like, gosh, I just don't know if I did this correctly. Use your calculator to check it. Just because I asked to see the geometric formulas doesn't mean you can't also type it in to make sure that you have it done correctly. So second trace, number 7. Start at -2. Stop at +2. 6.28, yeah, that is 2 pi. So you did do your area formula correctly, and you did get the part of the circle here. All right. Let's try the next one. Oh, piecewise graph. Okay. Well, I'm going to give you a table of values to work with. See what you can do. 0, 1, 1, 2. Just graph both pieces. Graph both pieces and see what you end up with. Most of these are lines and circles. The graphs are not going to be anything besides that, because then you wouldn't know the area formulas. They've got to be lines. Rectangles, triangles, trapezoids. The circle's the only tricky one that's got the squares in it. Okay, 0, 1, and 2. So we get, I'm going to go closed points, open, close. Just a reminder to myself what kind of endpoints I have. Okay. And 2 minus a 1 and 0. Okay. And shade. The area under the curve from 0 to 2. Well, it's just 2 sections. You got a trapezoid and a triangle. That's it. Just because it's piecewise just means you probably have 2 pieces. 1 for each section. Delta x over 2, y1 plus y2, 1/2 base times height. So 3 over 2 plus 1 over 2, 2. Okay. Let's do the last one. So let's put out our table of values. -1, 2, right? I've got the dividing section, and 2 to 4. Closed point, open point, closed point. All right, draw your shape. Okay. So -1, it's just, okay, so that's a horizontal line, closed point, okay. 5 minus 1/2 times 2, so that's 4, okay. And plug in 4, 5 minus 1/2 times 4, so that's 5 minus 2. That's here. Okay. And shade. Well, remember, we are only shading to the x-axis. Most of the time, these things are in order. Now, I'm going to do this little divider here because I see a rectangle. You're going to have to pick out the shapes that fit exactly. Right? Rectangle. Maybe I do rectangle. And then maybe I do triangle. Maybe those are the 3 shapes that I see. 2 rectangles and a triangle. 1, 2, 3. 1, 2, 3, 4. Notice you've got to use your diagram to get your shapes. 3 times 4. 2 times 3. And 1/2 base times height. 12, 6, and 1. 19 is the area.